sorry. That's what I forgot to bring now. Water. Anyhow, we'll deal with that just now. You guys doing some work. Okay, so we up and running there. We up and running there. Let's see who else needs to come in. All right, cool. So I'm going to take my roll real quick to see who is here as opposed to who is not here. All right, so Aisha is here. Let's see, Christian. D'Angelo is here. Donovan is online with us. Juliana as well. Hanifa and Jaden are here. Javed coming on Monday. Jaziri here, not seen Josiah. Jolie here, Khalifa here, Liam here. Logan was here from PoA. Noah here, Nyla here. Paige went home. Zianis. Okay, so basically everybody up and accounted for. All right, folks, good afternoon. Sorry for the slight late start. We started the May 2024 paper 2 on Wednesday gone, right? So we didn't get too far because I was explaining the question 2, which was the one that gave a lot of trouble last year, right? So we gonna see how far we get today, right? Now, of course, y'all could work ahead. You're very much free to work ahead, do the questions in any order, because sometimes there might be things you forgot how to do. Do what you can, all right? Now, I'm gonna go through this question because a lot of y'all were asking about it because you had not yet done transformations in school, or you did it and it didn't really resonate with you, all right? Okay, so the diagram below shows a shape T. And actually, I know what I could do, Jaden. I could print them on as we go along. There you go. So just give me a minute to print this out for Jaden. Right. Make sure. Okay, cool. Right. Just one copy. Yeah, we're good. Good to go. All right. Tammy, right? Oh, it's Logan, right? All right. Hey, Logan. How you doing? All right. We're now gonna start talking about the question 3 part C from last week that we didn't get to. Hey, Ladybug, how you doing? 82? Was it 1982? That's the year I was born. Right, so the diagram below shows a shape T and its image Q after a transformation. Okay, so transformations, we have a few after all. So we have reflections, rotations, enlargements, and translations, right? So this one here, so some people thought it was a rotation, and I could see why they might think that, because it shifted from here down to here. But the thing is, if you rotate something, so for example, if you had a triangle, right? And you rotated it, let's say going this way. What would happen is it would kind of, sorry, one sec. It would kind of end up looking like this, right? So you might say, well, look, it did change, but if we had to do a similar transformation with the triangle, what would end up happening? Is that it would end up looking kind of like this. But that's not a rotation, right? It almost looks like it's flipped, right? So this transformation, so diagram below shows a shape T. So T is the original shape and its image after a transformation. So T is the original image. It says here, describe fully the single transformation that maps shape T onto shape Q. Okay, so shape T onto shape Q. So long story short, this is a reflection. All right, and how we know it's a reflection is like this. If you were to look in a mirror, your image, your reflection, right, is what we call horizontally flipped or laterally inverted. If you raise your left arm, your image, your reflection appears to raise its what? Right arm. If you raise your right, it appears to raise its left. So there's a lateral inversion, right? That's why the letters kind of go the wrong way, etc., etc. Right? Now, the other thing, and one of the more important things to remember with a reflection, has to do with what we call apparent distance. What does that mean? If you stand in front of a mirror and you raise your arm and you touch the finger with your with your fingertip, the distance from you to the mirror is your arm's length, not so? But if you do that, does your image appear to do the same? Yes, it does. Which means that in the mirror, the distance your reflection is from the mirror, the apparent distance, because it's not actual distance, the apparent distance is the same. So what that means is that your reflection is the same distance from the mirror as you are from the mirror. So with the shapes here, there clearly is a line somewhere between these two, right? As a matter of fact, that's the exact line. I happen to draw it spot on. And that is actually the line y is equal to x. Now, apart from a fluke, we need to know how to get these things in a mathematical way, a scientific way, right? So describe fully the single transformation that maps T onto Q. So the transformation is that it is a reflection, right? And reflections take place through what we call an axis of reflection. So that pink line, that is the axis of reflection or the mirror line, right? So we need that. And that line, so reflection in the line, or the straight line rather, y is equal to x. Now, how can we tell? Now, usually what we would do is we would actually join what we call the corresponding vertices. What's a vertex? Well, vertices is the plural of the word vertex, right? So like this, oops, that is way too big. Yeah. So this vertex here and this vertex here correspond. So what you would do is you draw a straight line, sorry. I thought I would have, yeah. You draw a straight line connecting them. And all of the other corresponding vertices, you would draw lines connecting them as well. Right? And then how we get the axis of reflection is we have to find what we call the perpendicular bisector, or the halfway point along these lines, right? Now, if we zoom in a little bit, let's take this first blue line, right? Looking at it diagonally, it crosses how many squares? 2 squares, right? So if you want the midpoint, mid implies what fraction along the way? Half. So what's half of 2 squares? 1 square. So if you count this as 1 square and this as half, right? It means that this point here was the midpoint, right? This, hold on, let me change this vertex real quick. This line here connecting this vertex to the other corresponding vertex, right? That's how many squares does it cross? 1 square. So you have to find the kind of halfway point, which again, you can kind of average out. If you count the number of small squares, 1, 2, 3, 4, 5. What's half of 5? 2.5, right? So 2.5 will put us exactly in the middle there. Right? Now this, the longest connecting line here crosses 1, 2, 3, 4 squares. So what's half of 4? 2. So if you count 2 diagonals from either direction, you'll end up here. And the last line connecting 2 corresponding vertices is again just crossing 1 diagonal. So you find half of that. So when you then connect all those points with a single line, you get the line y is equal to x. Now it's called y is equal to x because, well, actually let me draw it over properly, right? Because I just kind of drew a random line and it happened to line up with exactly what I wanted at that point in time. Okay, right. So it's called the line y equal to x because at every point on the line, the value of y is equal to the corresponding value of x, right? At this point here too, the value of y is equal to the value of x. At this point here, y is 3 and x is 3. At this point here, y is 4 and x is 4. So that's why it's called the line y is equal to x, right? Because at every point along the line, y is equal to x. Right, so that's the first part, right? Describe fully, the single transformation that maps T onto Q. So you get a mark for saying reflection, and you get a mark for saying in what line. All right. Now, the follow-up to that is that it says on the diagram above, draw the image of shape T after it undergoes a translation by this vector here. Right? So this vector here has components -1 and 6. So a vector has 2 components. The top one is the horizontal component, and the bottom one is the vertical component. Right. So the horizontal component tells us how many spaces we're going to shift each of the points in the original shape, and the vertical component tells us how many spaces vertically. So horizontally, we could go left or right. Now there's a minus in front of that one. So a minus indicates which direction, left or right? To the left. And the 6 is positive. Which direction does that indicate? Up or down? up. So in this case, right, we're going to go left, 1 space, and then we're going to go up 6 spaces. Right? If it was a positive horizontal, we go to the right. If it was a negative vertical, we would go down. Oh, could you get that, please? Thanks. There, just give us 1 sec to see who's at the door there. Oh, hello. Oh. Okay, hello, is you okay? It's very nice. What did I get? Hey, boy. All right. Okay, so what we have to do is shift this whole shape left 1 space and up 6. Now, do we shift the whole shape or do we just shift the vertices? So, as a matter of fact, instead of trying to overclutter the diagram, what I'm going to do is I'm going to copy and paste the same page so I could erase all the extra stuff on it so we can see just that translation, right? So, let's start with one spot, right? Let's start with this vertex here. So we have to go horizontally first. Because it's a -1, which way are we going again? Left or right? We're going left. So we're going left 1 space, and then it says 6 on the vertical, right? So how many spaces up we going? We gotta go 6. So we have 1, 2, 3, 4, 5, 6. So that goes here. All right. Now you can proceed to translate the rest of the points just like that, or you could look at the shape and draw the shape based on what you're seeing. What do I mean by that? Okay, look. From this original point here, we go across how many spaces to the next vertex? 1 space. So you could go across 1 space here, right? Hold on, is that showing up? No, it's not showing up that well. Okay, give me 1 sec. Oh, was that a thing? No, right. So we go across 1 space. I know the line is not perfectly straight. Sorry about that. Right, and then also, if you consider this same original vertex here to this one, how many spaces we had to go down? You had to go down 2, right? So you could draw a next line there. And then from here, how many spaces we had to go across? We had to go across 3. And then all you have to do is connect that back. And it says to label it M. Right. And that's all you have to do. Right? There are longer ways we could go about doing this. We could get each of the coordinates of each of the vertices and add the transition vector to each of them, but I don't think that that's an efficient use of your time, right? You're in an exam, and there's only 1 mark, right? So it can't be that you have to do all that work for 1 mark, right? So that's how we use a translation vector, right? So again, the translation vector, sorry, 1 second, I had to change that, weight on that point, right? Right, so the transition vector was -1, 6, which meant 1 space to the left and then 6 spaces up. Right? So you could have used any point as your starting point. You could have I used this top right vertex. You could have used this bottom right one. You could use the bottom left one, any one. All you have to do is shift 1 and then copy the diagram based on the original. Or you could shift all 4 vertices if you wanted to. All right? Okay, so I'll give you a minute or 2 if you're copying anything down. Let's take a little. Does anybody want fries? Okay. Yeah? I have a banana soft drink. Anybody want a banana soft drink? No? Not a big fan of banana. Okay. All right. So Aisha, D'Angelo, Donovan, Juliana, and Logan. If you guys are good with what I have on the screen there for the translation, just give me a quick Genie chat. Right? If you need me to re-explain either this or the reflection, give me a R. All right. Oh, okay. Okay, I got all 5 Gs already. All right, cool. All right, in class, people, does anybody have any questions on the translation Oh, you didn't want all? No, no, no. Yeah. Any questions? Anybody? Anything? We good? Cool. All right. So, folks, we move on to question 4. All right. So, crap. Just now. I just get a visual. What's going on here? Right, give me one second. Let me just shrink the page a little bit so I could just print it off at Jadon. All right, cool. Oh, here's Janaya. Hey, evening, Janaya. How you doing? Good to have you on. All right. We do need May 2024 paper, so let me just one sec. Hold on, just now. Do I have an arrange? Arrange. New doc. No, I don't have an arrange. That's dumb. Anyhow, all right, cool. Hey guys, so give me one second. I'm gonna just resize my window here. Oh, Mishka, excuse. I printed out 2 pages for Jadon. Okay. One sec. Um, okay, so what I've done is I've I opened a second instance of the file, so that way we could see part 1 and part, well, A part 1 and part 2 at the same time. So we have, sorry, what did I do there? I don't even know. No, stop it. All right, cool. Okay, cool. Right, so I'll give you guys a few minutes to sort that out while I take a little bite of my sandwich. Right, so it says a rectangle PQRS is a diagonal PR, where P is the point minus 310 and R is the point 4 minus 4. So they want the length of the line and then they want the equation. Yeah. No. So I'll give you a few minutes to get a bit of a head start. If you're not sure what to do, you don't need your formulas, let me know. I'll put them on the screen. Or you can always ask me, sure. I send it from my Google Meet. If you guys need some help, let me know how to help you. If you need your formulas. All right, folks. So let's take a look and see what we have here. Right. So the length of the line, right? So the length of the line is given by it's a Pythagoras theorem formula. All right. So you can do x2 minus x1 squared plus y2 minus y1 then squared. And of course, it's squared in that whole thing. So again, we could label them x1, y1, and then x2, y2. All right, so that's right. So you have minus 3 minus 4, or you could do yeah, well, it doesn't matter. You could do minus 3 minus 4, then squared, then plus 10 minus minus 4 squared. All right, or if you did 4 minus minus 3 and then minus 4 minus 10, you end up ultimately with the same values. So minus 3 minus 4 is minus 7. So you have minus 7 squared. 10 minus minus 4 becomes 10 plus 4. 10 plus 4 is 14. So you have 14 squared. Now minus 7 squared is not minus 49. When you square something, what are you actually doing? Multiplying it by itself. Right? So when you multiply a negative number by a negative number, when you square a negative number, you get a positive. So you have 49, and then 14 squared is 196. Right? So 49 and 196, so that's 195 and 50, so that's 245, I think. Please correct me if I'm wrong, eh? So you just plug that up in your calculator, so 245 squared root. So about 15.65, 15.7, right? So 15.7 units. All right, correct to 3 significant figures. All right, blessed night cupcakes, how you doing? Good to have you on. Hey, Calls Cloud and Nick X, how you all doing? Or Nick? Not sure. Right. That's the gate again. Hey, Jacob, good evening. All right. Well, wherever you get a seat, I'll see if I can print out something for you just now, right? Are you gonna see the board if you're facing that way, boy? Your turn. The chair don't swivel. One second, guys. Let me just print out something here for Jake1. Oh, crap. Yo. -7, because -3 -4, right? If I have -3 -4, if you think of your number line, right? So you have 0 here, -1, -2, -3, -4, -5, right? So -3 is here. If I'm minus in 4, -3, -4, I'm going 4 spaces to the left, right? So if you have things like this, you add them together and put back the minus sign. Yes? No? Maybe? Huh? Mm-hmm. Four minus -3. Right. So when you minus a minus, that becomes a plus. And 4 plus 3 is 7. And when you square 7, what you get? So like I said, it don't matter which way you put them. Because ultimately when you square them, sorry, say again? Okay, I'm going to explain that one now. Okay. All right. So, the equation of a straight line, one of the forms called the gradient intercept format is y is equal to m by x plus c, where m is the gradient and c is what we call the y-intercept. What the y-intercept is if you have your y-axis and your x-axis, the y-intercept is the point on the y-axis through which the line passes. And at that point, x would be 0, because on the x-axis, on the y-axis, no matter how high up or how low down you go, x is always 0, because the y-axis literally passes through the point 0 on the x-axis. All right? Now, how we have to find that. It's not given to us, right? Now, what they're asking us for here is the equation of the line PR. All right? So to find that equation, we need to use one of the coordinates for P or R. So what I'll do is I'll use both sets, just to show you that it doesn't matter which one you use, right? But what we need is the gradient. To find the gradient, we have to find the difference in the y coordinates and divide that by the corresponding difference in the x coordinates. So as I say, y2 minus y1 divided by x2 minus x1. So y2 is -4, y1 is 10, right? So that will give us, what happened? Oh, I wasn't sure if it was like a small cow or a big mosquito. Yeah. -4, -10, and then x2 minus x1. Oh, sorry, one sec. I forgot to put on my little breeze here. The laptop getting hot. Right, minus 4 minus 10 over, right, so minus over 4 minus minus 3. So here we again have a minus minus, 4 minus minus 3. So minus 4 minus 10, they're both negative. So what do? We add them and put back the sign. Minus 4 minus 10 is minus 14. And 4 minus minus 3 becomes 4 plus 3. And 4 plus 3 is 7. And a minus divided by a plus is a minus. And 14 divided by 7 is 2. Right? So we have minus 2. So what I'm going to do now is I'm going to show you all how to use this equation in conjunction with the gradient. And I'm going to do it twice. One with the coordinates of P and once with the coordinates of R. Just to show you, it doesn't matter which one you use. Once you do it correctly, you're supposed to get the same equation. Right? So let's just... Okay, hold on. It's thick. So it does a function of having two different windows open. Oh, okay. It said no. Oh, okay, here we go. All right, so I don't have my two windows anymore, so I'll see if I could open them and just resize them again. Okay, cool. So let's do one in blue and one in orange. Why not, right? So we'll do a little separator line. Oh, that is way too big a point. Way too big. Right. So let's say using coordinates of P. Using chords of P. What are the coordinates of P? That's in minus 3, 10, 1? Oh, sorry, hold on one sec. No. Hello, Mom? Yeah, one is for me. Yeah, one is for me to carry you. Yeah. Oh, okay, cool. Right. So this is the x coordinate here. This is the y coordinate. And again, we're using y is equal to m, which is the gradient, by x, then plus c. So y is equal to 10, m is equal to minus 2, x is equal to minus 3, and c is the unknown constant, which we're trying to find. So when you multiply minus 2 by minus 3, a minus by a minus is a plus. 2 by 3 is then 6. So to solve for c now, we could subtract 6 from both sides. Or you could look at the equation and say, if 10 is equal to 6 plus something, there's only one number we can add to 6 and get 10. What number is that? Yep, 4, right? To show the working, again, you can minus 6 from both sides of the equation to give a value of 4. So now we can state that the equation is y is equal to minus 2x plus 4. All right? Now, again, I'll just work it over in the orange just to give you the visual that it doesn't matter which one we do. Right? So now we're going to using coordinates of R. And the coordinates of R, if I am correct, are 4 and minus 4, yes? Right, so we have the x coordinate and the y coordinate. And again, this form of the equation of a straight line, the gradient intercept form, is y is equal to mx plus c. All right, so the y value is minus 4. M is minus 2, that's the gradient. The x value is just plain old 4 plus c. So a minus by a plus is a minus. Sorry, I wrote the wrong thing here. Minus 2 by 4 is minus 8. And now, to solve for c, you have to kind of take away the 8 from both sides. Well, the minus 8. So when you minus 8, you get plus 8. So minus 4 plus 8 is the same as saying 8 minus 4. 8 minus 4 is 4. All right? So the equation, therefore, is y, again, is equal to minus 2x plus 4. Right? Both of these being the exact same item. Question? All right. So what I'll do is I'll take a picture of these couple of things and send them in the chat. Let me just take off this item here. All right, so I'll send some pics in the chat as we go along. So if anybody needs to go back and check it, you can. Okay. All right. So Google Meet. Hold on. Let me go back my arrow. Okay. So where? All right. There you go. Right. So Aisha, D'Angelo, Donovan, Juliana, Janai, and Logan. If you guys are good with what's on the screen currently, just give me a quick Genie chat. And that also goes for the previous part of the question as well, right? If you need me to rework or re-explain. Oh, okay, cool. All right, in class, people, have you any questions on either part one or part two? The length of the line or the equation? See, I know we're in the corner there, all right? You want to join us on this side or you're too cool? So you're kind of far, you want to join us a little nearer? Oh, you're good there. You're good there? All right, okay. Mandego Central people, how are we feeling with this? Any questions, anybody, anything? No? All right, cool. Non-Dago Central. So, Kirasi, Fatima, St. Anthony's, and HSC Wallace Spain. Good? All right, cool. All right. So, let's take a look at 4 part B. All right, so I guess I could zoom in enough so y'all could actually, no, I can't. Yeah, what happened there? 4 part B. No, come on, man. Philip, behave yourself. All right, hold on. Let me see if I could do that thing where I split it up again. New window. All right. Hold on. I wonder why. Why doesn't it give me a top and bottom split? Why is it always a left and right split? All right. Okay. So hold on. Okay, so this is 4B, part 1 and part 2. I think this is all that it is to question 4. So I'll give you a couple of minutes. Again, this is functions, right? And here they did simple and difficult because normally they just give you like a single value to plug into the function. Here, they give you an expression to plug into the function. But again, in case you're not sure what to do, right? It's substitution is the name of the game. So if this is f here, right? And you have to find f of, sorry. And you have to find f of x minus 2. What you're going to do is you're going to sub this entire function in place of x here. All right, okay. And then the same thing for g, right? If they want g of x squared, you're going to, 1 second. You're going to substitute, oh, how'd I come down here and do it too? Yeah, the 3x plus 2 inside of here. So you're actually going to square that entire thing and then add 10. All right, so I'll give you a couple of minutes, and then from there we will correct and move on. Adapt class network either 2.4 or 5. It does? Yeah, I don't know why. My TikTok one had dropped a while ago, then it came back. But I'm not coming and see if I can help now. Oh, okay.
where BTX you're putting it. So it's the same kind of context. So we know g of x is equal to x squared.
We're going to correct in like a minute or two, more or less.
So for g of x, whenever I see x, I'm going to put this. And then at the end of my equation, after this, I'm going to put plus this. So g of x, well, g of 3x plus 2 x time is going to be this squared. Plus 10.
Hey, Pitabi, good night. How are you doing? Good to see you on. We're doing some maths tonight.
If I put g of 4, will g of 4 be equal to?
Alright, let me see if that goes to print. Because last time I sent stuff to print from this laptop, it did not. And I have no clue if that's because it's on the wired side or if it's. Yeah, that didn't work.
So we know g of 4 is equal to 4 squared. So I'm going to substitute where g of 4 is.
So then go. Oh.
4 squared.
Alright.
And then these are still have 1. So I'm going to add 1. And follow it to what? Okay. So now they tell us.
Alright, so let's see if we could organize this right.
10 plus 2. What would that be equal to?
Okay, so once again, substitution is the name of the game. So if this is the function for f, 3x plus 1, and they want f of x minus 2, you're going to sub this in place of the x. So basically, it is 3 by x minus 2 plus 1. Now, functions is my favorite section. Yeah, functions is nice. What's the understood operation between the coefficient 3 and the bracket x minus 2? Anybody? What's the understood operation between the 3 and the bracket? Multiplication. And we use distributive law to multiply, right? 3 by x and then 3 by minus. So 3 by x is going to give us what? 3x. 3 by minus 2 will give us minus 6 and then plus 1. And minus 6 plus 1. So again, they have different signs. So you subtract them and put back the sign of the larger number. Minus 6 plus 1 is minus 5. That's the first one. But the second item, which is g of 3x plus 2 then plus 10, we are substituting that inside of here. So you have to square that entire bracket and then you're going to add 10. Alright, so that's equal to 3x plus 2 squared then plus 10. Right? If you know your perfect square identities, you know exactly what you're going to get when you expand. If you do not know the identities, I'm going to work it the long way. So when you square something, what are you actually doing? Multiplying it by itself. So 3x plus 2 squared is equal to 3x plus 2 multiplied by 3x plus 2. So we're going to multiply each term on the inside. So 3x by 3x will give us 9x squared. 3x by 2, so 3x by 3x, 3x by 2. 3x by 2 is just going to give us 6x. 2 by 3x is also 6x. And 2 by 2 is equal to 4. Right? And 6x plus 6x is 12x. So now we're going to bring that back across to the left-hand side with the green. So again, 9x squared plus 12x plus 4. Plus 10, and now 4 plus 10 is just going to give us what? 14. All right, cool. Let me send this in the chat.
So if this is g of x, well, sorry, g when 3x plus is this, what do you think g 3x plus 2 is?
Sorry.
Okay. So when you produce this,
Okay.
right there, it'll give you your answer. So what you're gonna do.
Okay. So I'm gonna check my online people first, right? So we're in the row. So D'Angelo, Donovan, Juliana, Janaya, and Logan. I think Aisha's left. Okay. So if you guys are good with that, just kind of give me a G in the chat. If you need me to re-explain any particular aspect, that's not a problem. Okay, so all four. Okay, in class, people, are we okay with the functions part there? Visible on the screen? Any questions? Anybody? Anything?
What's 3x by 3x?
Anybody? Any questions? Anything?
Remember, I'm multiplying our constants.
No? All right. So I'm trying to send pics as we go along in the chat, so we'll see how that goes. Yeah? Well, when you're ready, you can let me know. All right? All right, cool. All right, so maximizing here. 5 part A, 5 part B, 5 part C. All right. So, all right, okay, you're going all right. I'll see you tomorrow for hard maths, right? What have you all been doing in school since the last time we met? Huh? Quotient rule? Well, when you come tomorrow, bring a book now, we'll take a look. All right. You went overtime tonight, boy?
Yeah.
All right. Exam coming up. All right. Yeah. Just now, let it finish, print. One. No, there are 2 copies of each. One is for Jade, one is for Jacon. So they're next to each other. So you could do like left, right, left, right, left, right. All right, let me see if I could do a top and bottom for this one as well, guys. Let me see what I can do. Yeah, no problem. Okay, right. Oh, no. Right, that'll work. There it is. Okay, you know what? I done with that. It was on the screen? Yeah. That's question 5, yes. All 3 parts, A, B, and C.
With replaced ones. So that means that this is independent events. You need to change up anything. So probability.
All right, so all right, let's take a quick read of the question, right? So Mr. Morgan administered a spelling test to his class. The table below shows the number of words out of 10 that each student. All of us sound like Bugs Bunny front here. Come, we're reading. The table below, right, shows the number of words out of 10 that each student spelled correctly. Right? So 5, 6, 7, 8, 9. So the number of words correct is the top row here. And the frequency is the number of students who got that number correct. So 8 students got 5 out of 10, 4 got 6 out of 10, 2 got 7 out of 10, etc. All right? What's up?
This one, just checking quick. So you find the probability of picking I, find the probability of picking B and multiply them together.
Yeah. Right. So they want the mode and the median and then the mean number of words spelled correctly. So again, I'll give you a few minutes. If you know what to do, those who do not know what to do, well, we could walk around and take a look, right? Those online, again, if you know what to do, cool, go ahead. If you don't know what to do, let me know. I'll see if I can help you by sharing some tips.
Oh, your mediums are
or guidance.
So for this, you're gonna have to find n plus 1 multiplied by 2. That'll give you your rank. So the first thing you do under your frequency is find your cumulative frequency. Do you know what I'm
Right
talking about?
target. Ah.
Number of words is X.
PoA test. Okay, cool. What topic, Peter? What topic you have the PoA test in?
X is what? 5 to 10.
If it's still there. Might be gone by now.
Straight out my frequency. Next, yeah. Is my number plus only once before. So this will be 8. 8 plus 4 is 12. 12 plus 2 is 14. 14 plus 2 is 16. 16 plus 2 is 19. 4 plus 19 is 23. Exactly. Great. So when you're finding your median in Q1 or Q3, you're finding your median, which some people also call Q2. That's gonna be
Okay, Tony. When's it then?
Yes.
Oh, I think we're doing it online though.
Okay, cool. Oh yeah, I think it's Kayla's birthday Thursday, so she doing some stuff Wednesday. Oh, okay, cool.
And then 23 Tuesday, and then I will do it with
Okay, I hear you. All right, later. All right, stock valuation. Okay, yeah. Well, tap that there and only pass it for questions too.
So 23 is my total CF. So
Okay.
you're gonna be finding half of 24. Would be 12.
All right, so I'm gonna give you about a minute again to sort this one out, and then we're gonna correct.
Our 12 students is. So next to my CF, I like to do my CF range. Your range just consists of like what numbers you answer for. So this will be 1 to 8. This will be 9 to 12. This one be. No, 13 to 16. Cool. So I'm gonna look through all of my CF ranges, see which one contains 12. Which one contains 12? I'm gonna look at my corresponding X value. This is my median. So my median equals to 6. On the next page, you're gonna ask you to find your IQR in quartile range. IQR is gonna be equal to your Q3
Okay.
minus Q1. How you find that? Q3 is gonna be equal to
Let's
your
go.
1/4 and rank. So you know how you found the rank first and then the corresponding number. Same thing for your Q1, 3/4 n minus 1/4 by n.
All right, I'm gonna start this one here.
Yeah, so same way that you found your Q2, you're gonna find what Q3 is with respect to X, find what your Q1 is with respect to X, subtract them together from each other. Okay? You want me to run through your Q3 first? Yeah. Yeah. Oh wait, never mind. This is gonna be for this page. So it goes with your CF. So your total frequency, well your CF being 220, because this is group data, you don't do the plus one because the plus one, you don't know what all your terms are, so it doesn't make a difference between if it's like
All right, cool.
220 versus 220.5 if you have one. So you're gonna find your ranks on these. Find the number that you get on your CF. Go across till you hit the line. Find your corresponding time. Subtract them from each other. It's a bit. So if you want, you could find your Q1 and Q3 first. I'll check your answers and you can subtract them. Okay.
All right, Mishka, let's check the answer.
Sure.
All right. All right, ladies and gents, let's take a look and see what we have here, right? So, Mr. Morgan administered spelling test class. Table shows the number of words out of 10, and each student spelled correctly. So the first thing they want is the mode. So the mode is the number of words with the highest frequency. So long story short, whatever the highest frequency is, right, you read up to find what the mode is. Now, the biggest number in the frequency column is what? In the row. What's the biggest number in the frequency row? 8. And the corresponding number of words is 5. So the mode is 5. That is the number that appears the most time or has the highest frequency. Right? The median, right? So the median is the number exactly halfway in the distribution. But how do we know where halfway is? That's where adding the frequency as we go along to get a cumulative frequency comes into play. Right? So 8 plus 4 will give us 12. 12 and 2 will give us 14. 14 and 2 is 16. 16 and 3 is 19. 19 and 4 is 23. Now, 23 is an odd number. To find the median, whether odd or even, once you have either raw or, as we have here, ungrouped data, we take the number of, well, this is n here. We add 1 and we divide by 2. 23 plus 1 divided by 2. What's 23 plus 1? 24. 24 divided by 2 is 12. Now, we're not looking for the number 12. We're looking for the number that is 12th in the distribution, right? And if you follow your CF, the 12th item was actually 4, right? So items 1 to 8, sorry, no, my bad. The 12th one was actually 6. My bad, I said the wrong thing. The first 8 numbers. So if we were to write out all these numbers in raw form, so you end up with 5 8. So 5 5 5 5 5 5 5 5. And then 4 6s, 6 6 6 6. And then 2 7s, and then 2 8s, and then 3 9s, and then 4 10s. Right? This is 23 items here. And the item that is 12th, so you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 as 6. Or again, you can look here. It says, hey, up to the 12th item is the 6. So the median is 6. Right. And now calculate the mean number of words spelled correctly. So the mean number is the average number of words spelled correctly. So how do we calculate the average or mean of a data set? We add up all the observations or all the values and then divide by how many values there were. Now, we already know how many values there are because we added up all the frequencies. But in order to add up all the numbers, again, you could write them out one by one. So you'd have 5 8s. Then you have 4 6s, and you have 2 7s, 2 8s. What else we could do? Instead of adding up 8 5s, what we could do? We could multiply it by 5, right? So the way to find the mean, now you can denote the mean as x bar. And this is where we add up. So that symbol there is a Greek symbol called sigma, and it means the sum, right? It actually is a capital S, although it looks like a kind of weird looking backwards, well, weird looking E. So we add up all of the products of the frequency by the observation and divide by the sum of said frequencies. All right? So what did we have? Sorry, you know what? I'll do it on the top. No, be yourself. Right, so we had 8 5s. So in the first bracket, we have 8 by 5. Then we have 4 6s. Then we have, I might run out of space here. Okay, no. I think I have it. Then we have 2 7s. Then we have 2 8s. Then we have 3 9s. And then we have 4 10s, right? 4 by 10. And we're dividing all of that up. So again, if you want, you can put the 8 plus the 4 plus the 2 plus the 2 plus the 3 plus the 4. But we did it already to find the median, so you don't have to do it again. All right, so let's maximize this one. Okay, so 8 by 5 is 40. 4 by 6 is 24. 2 by 7 is 14. 2 by 8 is 16. 3 by 9 is 27. And 4 by 10 is 40. All over, as you said, 23, right? So 40 and 24 is 64. 64 and 14, 78. 78 and 16 is 94. 94 and 27 is 121. 121 and 40 is 161. Please correct me if my arithmetic is off, eh? Let's double check. So 40 plus 24 plus 14 plus 16 plus 27 plus 40 161 divided by 23 is exactly 7. Look at that. So the mean, the arithmetic mean here is exactly 7. All right, so actually I'm just going to copy that. Okay. All right, okay. So just for this page, so my Google Meet people, right, if you guys are good with the mean, the mode, and the median, just give me a quick Genie chat, please, and thanks. I'm going to zoom back in just now, right? I'm just going to send this in pieces. What we have? Oh, wow. Wow, okay. I don't know how that happened. But all right. So let's cut that. And we're gonna put it back down here. Oh, brilliant. Okay. Thank God. All right, cool. 1, 2, 3, 4. All right, cool. All right. In class, I'll ask you all just now. So of course, if you have any questions. Oh, sorry. I see now a picture here. Excuse, what value you got for the interquartile range for the next part? What value did you get for the interquartile range? 21. So yeah. Q1 is 33, right? Right, okay. Right. Yeah, so D'Angelo, you may want to check over your work in there. Right. Hey Timmy, your vibes. Right. But I'll go into that one shortly. So you'll see the solution shortly. Right, so like I was saying, let's zoom in. I got a couple of pictures going there. All right, cool. All right. Okay, thank you. All right, in class, people, have you any questions on this part? 5A, B, or sorry, 5A? Oh, yeah, we cool? Yeah? All right, lovely. All right, so we're going to take a look at 5B. All right, so I think I might talk you through 5B. All right, so it says the attendance officer at a particular school recorded the time T in minutes taken by each student to travel to school. Each student in a group to travel to school. The data collected is shown on the cumulative frequency curve below. Right, so the cumulative frequency is where you add up all the individual frequencies, and T is the time on the x-axis, right? So this comes from grouped data. So like where you have intervals like 1 to 10, 11 to 20, that kind of thing, right? So it says, using a CF curve, find an estimate of the number of students who took at most 32 minutes to travel. So at most, if you think back to our linear programming escapades back in January, at most means less than or equal to 32. So first things first, on which axis are we going to go to find minutes? The x-axis or the y-axis? The x-axis, right. So let's go there. So we have between 30 here and 40 here. How many spaces do we have? 1, 2, 3, 4, 5. So between 30 and 40 is how many? Is that a space of 10. And each of those blocks will account for 2 because there are 5 blocks that cater for 10. So the 32 reading is actually this first broken line here. So you read up to your curve, and then you read across to your y-axis to find how many students there. Right, so we have that. Now, on this axis, we clearly have a different scale. Between 40 and 60 is an interval of how many? That's 20. And that 20 is accounted for by a space of, by 5 little blocks. So if you take 20 and you divide by 5, how much you get? 4. So each of those blocks accounts for 4. So 44, sorry, so this is 40 here, then 44, then 48, and the next one is 52. Right? The next one would have been 56, and then 56 plus 4 is 60. So to answer this question here, the number of students who took at most 32 minutes is what? Is that 52? Right. So 52 students took 32 minutes or less. Right. I don't think there are any other questions on this part of the page, but let's go to part C and see what they want, right? They want the interquartile range. So I know some of you all worked ahead and some of you all still not sure how to do this interquartile range. The interquartile range, okay. The range, first of all, is the difference between the highest value and the lowest value. So the highest value clearly is what? 90. The lowest value is, well, possibly 0. The range is the difference between highest and lowest, so that would be 90. The interquartile range is the range of the middle 50% of the data. Now, why is that important? Because what happens is that on what we call the ends of the distribution, like the lower end and the upper end, you can have what we call outliers. Values that are either very high or very low. For example, you all know in your class, like most people might do, let's say 50, 60, 70, but you always have these bright people who do like 90 something, or these people who maybe not as bright, doing like 10s and 20s, who clearly don't understand the subject, right? So those are outliers, right? So people who definitely don't fall into like that kind of middle set of data. So what they do is they skew the average, they skew the mean. Now, what do we want to do with the mean? The mean is supposed to be a representative value of the entire data set. Like, for example, when we send up somebody from Miss Universe, she's supposed to represent the whole country. Does that always happen? No. Right? Sometimes can one person possibly represent the whole country? Not likely. But they can represent a certain proportion better than other people. So with an average, with a mean, what happens is similar. You want one value to represent the entire distribution. Again, a seemingly impossible task, but the quality of the representation can differ depending on what we call the spread of the data. The spread being the difference between lowest and highest. But we said that in the lower end and the upper end, you can have these outliers that cause the average to either rise or fall and become meaningless. For example, if we were to add your ages here, most of you all are between 15 and 17. You might have an 18 somewhere, right? So the average of you all might be 16. If you throw in my age, my big old 42 hours, right? The average would probably be 20 something. Is anybody in the class 20 something? Maybe Mishka, right? Right. But of all you, anybody in all your batch is 20 something? No. So the average would not represent any value in that particular set. So my age would be the outlier. It will skew the data and cause the average to be not meaningless per se, but not really reliable as a representative value of the entire data set. So we don't want that. So when we calculate the interquartile range, we cut off the two ends that could have the outliers and focus on the middle 50% of the data, where most of it's supposed to be what we call clustered. So we test the range there and we see if it's good. Now, what's the measure of good? We have none, right? So it's just a value we wanted to calculate. So how do we find this interquartile range? So when you hear quartile, what fraction comes to mind? Quarters. Let me see the data set was represented by, not that shape, but okay. This rectangle here, right? So quarters means quartile. Sorry, quartiles mean quarters. How many pieces, how many quarters in a whole? 4. So if we cut this data set in half, we have 2 equal pieces, right? How do we then get 4 from that? We cut each of the halves in half, right? So this is your first quartile, your 25th percentile. So your 0 to 25 is there. And the next quartile will go to what percent? 50%, right? So by the way, your median is your 50th percentile, that's Q2, right? And from 50, the next 25% markup is 75%, right? That's your Q3, that's your upper quartile, and then you have your 100 percentile here, right? I don't think we call it Q4, and it's strange that we don't have a Q4 since we have quartiles, right? But the quartiles cut the data set into 4 pieces, but you only need 3 cuts to turn something into 4 pieces, right? So the interquartile range is the upper quartile, so the Q3 is the upper quartile minus the lower quartile value. Upper quartile value minus the lower quartile value. So how do we find this now? So remember for the median, we found, we took the number of items and divided by 2. So here, to find the lower quartile, we could take n, the number of items, divided by 4. Go back to the graph. So the highest number here is, the CF is 220, right? Right. So if we take 220 and divide by 4, we will get 55. Now you're not looking for the number 55. You're looking for the value of time that corresponds to the 55th reading. Let me explain. Go back to your graph, and you're going to go on this section of it here. Okay, so I'm gonna have to erase this little piece, right? Actually, I shouldn't do that. Right. So this is 56 here. So 55 would be somewhere just below that line, right? So you want your 55th reading. So you go across and you hit your graph. That's almost the same spot, boy. Okay, well, let me go all the way across the next side, right? Boom. And then we go and go, but if we go down with the same spot. All right, so we're going to go down a little further. So it's about halfway between the 32 and 34. What's halfway between 32 and 34? 33. So your lower quartile is actually 33. Now for your upper quartile, right, that's the 3/4. So you could do 3n over 4, which is literally 3 multiplied by the n plus, sorry, the 3 by this. So you have 3 by 220 over 4. So that's the 165th reading. So you go back to your graph. You find where the 165th reading is. All right, let us zoom out a little bit. Okay, let's get a different color, no? Why not? Behave yourself. Right, okay, right. So how much you said it was? Right, so 160, so 164. So 165 is just above the 164 line, right? And it follows that line, that broken line, all the way down. And that is 54. Which can you 54 as the upper quartile or something close to it? Yeah? Right. So we have 54. And 54 minus 33 will give us 21. And that is your interquartile range. All right, so I'll give you a minute or two to kind of let that settle. But of course, if there are any questions, now would be a good time to ask said question. Yo. Yeah, no problem. Organize. Right. Okay, Google Meet. Just give me a quick G if you're good with that. If you need me to go over, it's not a problem. Give me an R for re-explain. Right? Well, let me know. Yeah, actually, you come back. I see you. Right. Okay, cool. So that's 3. All right. But the rest will let me know when you're ready. All right. So again, they have a habit of doing that. I don't know why, but maybe that's just the way they learn it. Well, I can understand why you could, but most times the notes are good. So if you could at least bring yourself to write the notes down, you'd have something from which you could go back and read. And even if it don't make sense, you could send me a pic, you could send it to Mishka, whoever, and say, hey, no, I was just telling them, if you actually get a message. Right, cupcakes. So can you explain these simultaneous equations to me? If I had time, that's the issue, if I had time. But send them through now. Send them through. What you could do as well, cupcakes, message me, DM me either here on TikTok or in Instagram and say, hey, it's Cupcake 20 Live. So what I can do when I work them, I can send you a picture. All right? Because right after class, I had to kind of shut down and hustle to home because wife only with the 3 kids now. So yeah, I just had to kind of dust it after class kind of fast. All right, but send it through once if I have a little time out there, all right? Okay. Okay. Right, so I'll leave this up on your screen for a little bit. Right. Hey Naya, and hey Jarrell, good evening, how you doing? And everybody else. Hey Gib, I didn't see you there, boy Gib. Oh, you're not pop one. I know you. What vibe? You good? How's school going? A long time no see since you like by up in the estate. Yeah. Yeah, sure. Yeah. I sent it in the chat already, yeah. But you could check it out, yeah. Yeah, no problem, cupcakes. Sorry, D'Angelo. sorry, let me go back. Yeah. Yeah, DeAndre, you're kind of, you're close. Again, the thing with the graph, sometimes it could be a little imprecise when you read it off, right? But they accept a range of values. I think 70 might be a little far. You got into 33 real good. I think I got 33 as well for the lower quarter, right? So you might just want to double check the 50, right? Right, yeah. Yeah, no problem. All right, cool. But thanks for sending the pics, by the way. I appreciate it.
Okay. So for this, when you're doing probability, okay, the first thing that you're gonna do is you're gonna find the probability of picking an I and find the probability of picking a B. When you're finding the probability of something, it's a number of variables.
This time. Oh, okay.
We have three I's.
No problem.
So probability and center answer is probability of picking an I would be 3/10. If there's one B in probability in positivity,
Yeah, send it on Instagram.
okay?
For sure, for sure.
Okay. So now they want us to
I could zoom in a bit better on that. Messaging up on TikTok. That's so great.
When you hear the word or, you add. So you want to find the probability of picking an I and B. So you're going to multiply your probability of picking an I by the probability of
3,400 likes. Wow, that's pretty cool.
So you said to find the probability of picking an I or a B, you add that. So 3/100. Yeah, I may not say mistake too. Alright, what do you multiply? You don't need to take out anything because it's just replaced. If it's without replacements, then
Flash out.
it's subtract. So you keep your own. So the replacement relaxers as they take your own. So if you just take that, you can system.
Was similar to mine. Oh no, there's not.
You okay with your probability?
Oh, thanks for the follow, Gerald. Appreciate it. Okay, cool. Sorry. Okay, so I'll start in a couple of seconds. I'm just trying to. I am alcoholic. Yes. Yes. Steven. Wow. Okay, cool. Alright, cool. That's the stadium. I'm trying to open my app and it's not opening. Stop. You. What? No, it's junk. Alright, cool. Alright, let's start here, right? Okay, ladies and gents, it says the letters in the word positivity are each written on separate cards and placed in a bag. Desha, right, picks two of these cards at random with replacement. Now, what that means is that she picks the card and she puts it back into the pack, right? So why that matters is because if she doesn't put it back, it actually changes the probability. For example, if I just had three cards, A, B, and C, and I say you win if I mix these cards up and you pull out the B, you win, right? So the probability of you winning is what? 1 out of 3, right? So there's only one B out of 3 cards. Now, if you pull and you pull the A, did you win? No. Let's say you were able to discard that card. In other words, you didn't put it back in the pack. Now, how many cards left? 2. So what's the chance of you winning now? 50% or 1 out of 2. So your probability has changed. If you put that A back in the pack and I shuffle it again, the probability of winning is still what? 1/3. So whether you put the card back in the pack or you leave it out matters to subsequent probabilities. All right? So The letters in the word positivity are each written on separate cards and placed in a bag. Deja picks 2 of these cards at random. So in other words, she picks a card, puts it back, picks a card, and put it back, right? Find the probability that she picks the letter I, then the letter V. So, right, this is one of the updates to the math syllabus, specifically with respect to probability, right? This sort of stuff, you wouldn't have seen it before, 2024, to be honest, right? Maybe 2023, but I think they updated it in 2022 for first testing in 2024. I'll have to double check that, right? But this is what you call independent events. If 2 events are independent, the occurrence of one event doesn't affect the probability of the occurrence of the other one. For example, if Jaquan in football score a goal in the match, that have no bearing on whether Noah falls asleep in class. Those 2 things are and vice versa. If Noah falls asleep in class, it has no bearing on. I'm not calling Noah sleepy. I just use an example. All right, Noah is very attentive, right? So, when they have independent events, the occurrence of each of them does not affect the probability of the other occurring. Now, they want the probability that she picks the I, then the V. Okay, we're going to find each of the individual probabilities. So, how many letters do we have in total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Out of those letters, how many of them are an I? 1, 2, and 3. So the probability that you pick an I, where this P stands for probability, is how many? 3 out of 10. Okay. How many of the letters is V? The probability of picking a V is 1 out of 10. Right? And now the probability of picking the letter I first and then, followed by picking a V second, is equal to the product of those of the probabilities of those independent events. I didn't mean to put first and second in the product. That changes stuff, right? So the probability of picking an I, hold on. Nah, I'm overthinking. It's a CSEC question, right? So it's simply the product of the 2 probabilities. So when you multiply fractions, what's the protocol? You multiply numerator by numerator. 3 by 1 is 3. 3 by 1 is 3. No, 3 plus 1 is 4. And 10 by 10 is 100. Right? And 3 out of 100 is 3. So you can leave it as 3 over 100. You can put it in percentage form, 3%. You can put it in decimal form, 0.03. All right? Okay, cool. All right. So with that now, right? Again, there aren't many past paper questions with this kind of probability question for maths for CSEC, right? This has been on the AdMath syllabus for some time. Not that it is AdMath level difficulty. It actually is a very simple concept. But there's not much to go on. You could always Google it. You could ask AI for help in terms of generating some questions to try with the solutions. Although you might have mixed results depending on what AI tool you use. And I'm not telling anybody to go and spend money on ChatGPT, right? Not that it's a bad thing or whatever, right? You know your budget. Yeah, okay. Google Meet, if you guys are good with the explanation for part C, just kindly give me a quick G in the chat. If you need me to re-explain anything, please let me know. All right, cool. Hey Chelsea, how are you doing? Good to see you on tonight. Okay, in class people, are we okay with part C, the probability? Any questions, anybody, anything? No? All right. Okay, we should finish again. All right, so let me just print this out for Jaden and Jaquan. Right, so of course, those who have the paper could go ahead. Oh, no, I wanted to print that. Now, we don't have too much time left, so we might have to fast track this question. You know what? Let me do one piece at a time.
Looking at all of this, the information that is equal.
Alright, so I'm just gonna give the printout to you guys in class so you can take a read in the meantime.
28, and your length is 8.72. If I substitute in the values that I have my area, and I have my length. They want us to find my cross section. So that would be 2.86 is equal to cross section multiplied by 8.72. So yeah, this is a half by multiplication, so you're going to divide both sides by that. This answer right here will be your cross section.
Oh no, that's not gonna work. Alright.
For your second part, your volume of this is your length by your breadth or width multiplied by your height. The second one. They want you to find your height, so you'll substitute in all the other
That's a pretty
values
interesting
for
name.
each. Is that okay?
That's a character from Rurouni Kenshin.
Yeah, so they give you your area and your length, so you're gonna transpose that up to find the cross section. For this one, they gave you
Oh wait, just
your
now, did I send a picture of the probability one?
volume, length, and width.
Sorry,
Transpose
give me one
to
second, let me double check that.
height. Volume of finding this.
Okay,
Your
sorry, hold on,
volume of all
my bad.
this
I had to go back a little bit.
is equal to your cross-section area multiplied by your height. You have your height
Sorry,
here.
I'll put that back up shortly.
You know what your area is right here. So if you substitute in, let me get. Hi, Anthony, cross-section, okay? Hi, cross-section.
Alright, so I'll give you a minute again and correct this piece. I'm sending for part 2, because I want to at least get to part B tonight. Actually, I might speed through this question. So, do what you could do. Hey, thanks, Gabe. Thanks very much.
Your volume
Hey, Julie.
of your shape, so volume is equal to your cross-section
Okay, cool.
multiplied by your length or height width. Is that okay? You okay with that? Okay. So in part A, they told us that the area, the volume of my shape is, so I'm just gonna write out what I have. My volume is 2886. And then from this diagram right here, this is my height. So that'll be 8.72. I'll substitute in the values that I have already. So I have 2886 is equal to the cross section, which you're trying to find, multiplied by 8.72. This is a top and multiplication. How am I going to transpose this? What's the opposite of multiplication? So I'm going to divide both sides by 8.72. So my cross section, which is what they're asking for, is equal to 2886 divided by 8.72. You get that? Okay, for the second part, the
Oh, Julie, there it is.
want
Okay.
us to calculate the volume of the keyboard. So they told us again, and this top. Okay. So
Oh,
when you're finding your volume of your
wow,
keyboard,
I didn't realize it was already up.
that volume, that formula right there is going to be length by your breadth or width multiplied by your height. They told us again in part A that our volume is
Okay, cool.
equal to
Amira, for cash book when doing
2.86.
the,
You
okay,
can see from here
doing the bank rec, what balance do we need it to be equal to?
our width
Hey, Amira. Okay,
is
so
3.6.
the cash book usually has to be updated using the bank statement first, and then thereafter we have to kind of update the bank statement using the cash book. I have a whole series on YouTube as to how to do bank recs. You can check it out. You can go on YouTube. The channel name is the same as here, Adaptation. And yeah, because it's a bit more in depth there. So I'll just give you a short answer, but you can find the answer. And of course, if it's a past paper question, you're almost bound to find it there, except Jan 2024. I'm still working through that one. But anyhow, and you can always DM me on Instagram or here. I respond more quickly on Instagram. All right. So if you need help, let me know. I'll see if I could facility. All right. Okay, ladies and gents, let's see if we can get through most of this question before today is out, right?
We did the same division
Okay.
Those are wrong. Let me see what happened.
Right. Okay, so it says in this question, take pi to be 22 over 7, all right? So the diagram below shows a gold bar in the shape of a trapezoidal prism. So what a trapezoidal prism is you have a trapezium or trapezoid as a major face, and you're basically extending that back into the third dimension, right? So you kind of, it's like, imagine you're on the beach and you take a stick and you put the stick in the sand, right? Let's imagine the sticks, the tip of the stick is perfectly round, right? So perfectly round implies what shape? Circle. So if you push that circle into the sand, you're carving out a cylinder. So a cylinder is a circular prism. Imagine it was a cooler instead. So most coolers have what shape as the bottom? A rectangle. If you push that down into the sand, you kind of causing the rectangle, which is a two-dimensional shape, to kind of travel through a third dimension, and you'll carve out a cuboid or a rectangular prism. If you had a perfect square and you push that down, it'll carve out a square prism, right? If it was a triangle and you push it down, and that shape is a triangular prism. So as we know, they have different names. Like the circular prism is a cylinder. The square prism is a cuboid, right? Sorry, a cube. The rectangular prism is a cuboid, right? So once you understand what the concept of a prism, right? Actually, and I found, I think I sent it to Mishka on TikTok too, a fourth dimensional thing. You all saw Avengers. You all remember the Tesseract, right? So it's actually a fourth dimensional hyper solid or hyper something. Anyhow, in higher dimensions, and they have more dimensions than that too. I have no clue how to even fathom that, but anyhow, different story. It's quite interesting. Anyhow, so the diagram below shows a gold bar in the shape of a trapezoidal prism. Its volume is that. The length and height of the prism are indicated on the diagram. Calculate the area of the shaded cross-section. The simple logic for the volume of a simple prism, and what I mean by simple is if you take a shape, like a two-dimensional shape, and you create a prism out of it, the simple formula for the volume of that solid is to find the area of that front face and just multiply by the height into the third dimension into which it is extended, right? Now this looks like height because it's going up, but it's not. That 8.72 is actually already part of the what? Of the initial front face. This piece here is the length into the third dimension in which it is extended, right? So the volume is equal to the area multiplied by, we'll call it h for height, which is this piece here, right? So 28, let me zoom it back in. Yeah. 86 is equal to 31, is equal to A multiplied by 31.2. So if I want to solve for A, how would I do that based on my statement here? I would simply divide by 31.2. Come on, man, Philip, stop zooming out. Give yourself. So 86 divided by 31.2 is equal to A. So 92.5. So 92.5 is the area of the front face. So centimeters squared, right? Don't forget your units, please and thanks, right? Now it says here, the cuboid-shaped gold bar has the same volume as the trapezoidal prism gold bar displayed on top. Calculate the height. So the logic here is the same. So the volume is the same, 2886, right? And they want the height this time, right? So volume is equal to length by breadth by height, not so? So 2886, sorry, 1 second. Come on, man, Philip. Right. So 2886 is equal to 30.6 by 8.2 multiplied by h. So how do we solve for h here? We divide by that product, right? So 2886 is equal to 30.6 by 8.2. Right, so 2886 divided by brackets 30.6 by 8.2. So we get about 11.5, right? So that's about 11.5 centimeters. Okay. Let me see what 6B is asking for real quick. Okay, now. Okay, so here what? When we come back, I'm gonna send a picture of this in the chat, right? When we come back on Wednesday, we're gonna round up questions 6, 7, and hopefully 8. Which means next week Monday is 9 and 10. Right? So please bring back your papers. Those of you who didn't have a full paper, I'll see if I can print out the rest of it for you. Somewhere, there was somewhere there.
Chris, can you pass me this? Oh, wait, no.
Yeah. All right, so Google Meet, that's about it for today, right? I think I sent, no, I was now about to. I had to see if I have cash, because if, worst case scenario, I could pay, wait, you coming tomorrow?
I think so, yeah.
All right, so if I don't have the cash, I can give you tomorrow, because I suppose I get some cash tomorrow.
Okay,
All
cool.
right, cool.
But I said it's possible for today, because
Yeah.
I want to go tonight.
All right, cool. I'll see if I have.
Yeah, thank you.
All right, so yeah, TikTok, I'll go, I'm sorry, how many TikTok? Google, oh, well, nobody did, right? All right, YouTube, sorry.
I'm just putting them over here.
All right, cool. Hey, Shanti, sorry, I didn't see your comment. I don't have my YouTube comments visible during class. Sorry about that. But I'm so happy to hear that